Okay, so I just want to do a very quick explanation here, right? For the past couple of months, I've been working on few stuffs, and it was really intentional, right? So I wanted to explore, um, not really explore. So I don't know if you can hear me. There's a lot of background noise actually, but yeah, but just try to hear me out. So but I've been exploring some stuffs, right? So what one of my concerns actually really was um, to build a tool, right, that um, can accept requests, right, both Web3 and Web2 requests, right, and deal with it like specifically based on the request that is coming in or item that is coming in or that needs to be delivered, right? um I started this journey by just exploring some individual products. Right, I built a webhook, I built a reverse proxy, I built a postgres flow, um and also, so this is just my repo actually, and also a Solana submission engine, right? So I want the goal of actually working with this tool or building this stuff was to help me really understand how these things work individually, right? And now first of all, um my first adapter was actually a Solana request. So I don't know if it makes sense or not, but yeah, that's just it. So I I I really want to summarize, like I really want to give an overview of like the full picture, the architecture. So what I want to build, so this is it. So in plain English, so can I read with me? So a durable execution platform that accepts supported API calls, webhooks, stores them safely, using our PostgresQL, right? Routes them through a tracked execution call, invokes the correct adapter, and returns explainable outputs through receipts, status, endpoints, and callbacks. So, and what this thing is not just a queue, it's not just a webhook relier, it's not just an RPC wrapper, and not just a Solana product. So Solana is the first adapter, actually, like I said, and not the identity of the platform. So, and my wage here is just that there will not be any silent failures. It will be a durable state, a clear life cycle transition actually, and replace safety recovery and readable receipt. So the these things I've test run them in most of these things I've built. I've test run it in my Postgres flow, test run it in my webbook, right? And also I've also test run it in this Solana submission engine, right? So the idea of using them individually is just to get a grasp of what is like. How can I structure this thing, right, to give me exactly what I'm looking for, right? Initially I didn't really found a good way that sits well with me, right? um so that's that's why I went like building it individually. Let me see how these things work. So and luckily for me actually I came out with something, right? So the architectural design of this tool is that the reverse proxy, right, will be at the forefront. So this share story is just a story time. I'll call it a story time, but there's um the design is it's just on paper. It's not on my PC yet. So the architectural design is that the reverse proxy will be on the forefront, that will do a lot of filtering and validation stuff, which the webhook also will validate, right? So the flow is that request comes from reverse policy as an API and enters into webhook, and then from webhook it goes into my our PostgresQL, um, and then from the PostgreSQL we have an executor, like an execution core. I call it execution core that sits inside our Postgres, right? That actually invokes the correct adapter based on the job at hand, right? So in our case now, our first adapter here will be Solana, right? So it will invoke Solana logic or Solana adapter, right? That will take in the information, the intent, wrap it, that stimulate cryptographic wrapping, and then stimulate sending it to the network, and using pull method to track whether this intent have been finalized or not, and return a very detailed feedback, right? Like a receipt format, right? and and then the callback follows the same method also. It goes back. Now the output actually is not logic based, right? The like the receipt output, right, is based on our source of truth, and our source of truth is the PostgreSQL, right? It's the the system is this is going to be designed in a way that the what's it called, there will be a track record of what happened in each layer, right? And everything can be queried via the UI, right? At the end of the day, it will be queried via the UI, and yeah, and it's Postgres only. There is no Redis, no Kafka, just pure PostgreSQL, right? And I will not say that I've done the hard part by using these individual tools, because I think this is kind of the more easier part, right? What I need to do now is just to set boundaries, right, and add contracts, and which is a very difficult thing. So this is what I'll be doing, right? And the goal is to um give each layer what it will handle, right? Give each layer what it should do and what it should not do, right? Make the set the boundaries clear, and yeah, that's just it. And so what will happen, why this architecture was designed like this, is so that um any API that is coming in, right, we follow a structured format, before reaching the adapter, and also the output we follow the same structured format, and we can be able to track what is really happening behind the scene. So it's not kind of a guesswork that, oh, did this thing went through, did it crash, or a guesswork. So you can really query what happened, whether it's the request succeeded or failed. There will be a detailed reason, right? And this reason is not actually based on vague stuff, right? The reason is based on what happened in your request progress, in your life cycle, your request life cycle. What happened, what was the event that happened that took this, right? And that's how the design pattern will be, which most of these tools, this firewall, I use also the receipt format to, I was trying to get a very good picture of how this thing will work, and yeah, which I did actually. So um so the why I didn't actually maybe fully did this Solana base, or just is so that both Web 2 and Web 3 can send in requests, right? And what we will need to do is now to deal with the adapters, right? So what we will do eventually is to build adapters that will adapt, like the name implies, to our core foundation, right? So the adapters is not something that you integrate into the system and it will break anything on the already existing tool. No, it have to adapt the already existing tool, right? And I think it's much more better that way and much more safer that way, right? And is much more scalable that way, right? Than building something that maybe that is fully just for one chain, which was not my initial goal. So the initial goal was just to how can how can these things talk to each other, right? How can they talk to each other? How can I build a system where um um information can pass through and there'll be a point where they'll be filtered, right? But there is no discrimination from this onset, right? So anybody can send in anything, provided that this system actually accept it, provided there is an adapter for this, the request being said or the intent, right? Then it will get to the point where each adapter will have their domain specific rules. Solana will be handling Solana specific intents. Let's say email will be handling email intents, webhook intents, stuff like that, right? And yeah, that was just the design, the overview of what is happening, what is going to happen at the end of the day. But yeah, but experimenting with these tools actually gave me an overhead of this, right? Um, to help me really capture capture the architectural design, how this thing should be. Because initially I didn't have I wanted something, but I didn't know how to structure it, how to make it happen the way I wanted. So first of all, I wanted to build a webhook, right? That emits events via Web 2 and Web 3. But that's not it didn't sit well with me because that's not really what I want. But this one, this architecture now, you can really build adapters for both EVM, both Web 2 requests, um any stack at all, any chain at all can actually be adapted into this, provided they follow the structural process, right? And yeah, that's just the beauty. And now the beautiful part is that your the life cycle of this process is very clear. So this tool is not really for everybody at the end of the day, sha. It's for people that maybe want to self-host using PostgresQL and at the same time they don't want the overhead of trying to um, send requests and be guess checking what is happening, what like there is no full detail of what is happening or what happened. They are just second guessing, right? So this the category of people this tool is going to be built for at the end of the day, or this the people I'm building this tool for at the end of the day, that you have um um, a request or an intent that went through a process, and you can query at what point that this thing failed and why it failed, reasonable reason why it failed, and a suggested action of what to do next, right? To make sure maybe that you get rid of the error or the mistake or know exactly what to do at the end of the day, right? So it just gives you that human readable reason of what is happening. Alright, so that's just the core of it, right? So at the larger scale, we are not expanding, right? We are going downwards, right? What we'll be doing majorly is to be adding adapters, and at the same time, trying to make sure that our foundation gives much more reasonable feedback, much more concrete and accurate reasons and receipts, like making sure that there is well detailed replayer, there is idiopotency, like it's much more solid, right? So we are not going trying to build add more features. No, we are going downwards to keep what we have stronger while adding more adapters at the end of the day. So that's the goal. That's the goal. Is quite going to be a journey, right? And yeah, that's just basically what it's all about. That's just it. That's just there is no much of a talk here, but that's basically what you're working towards at the end of the day. And actually, we will still talk about we will still work on the security aspect that handles who have to submit. Um, Actually, the PostgreSQL is handling that. You know, somebody that needs to say that the work is already done have to be the worker that handled the job, right? And to also know who to have to query this request, who have to handle what, right? There will be strict rules which admin have to handle with stuff, right? Just it will be just around these basic stuff. At the end of the day, it's not something spooky or something in the air, right? Yeah, that's just it. That's just it. So, um, this is where the job will now be trying to put these things together and create boundaries around them. Right. So yeah, that's basically. So I just wanted to show us this repo, and yeah, so but you can just come here and just explore and have fun. So this TX firewall was just a transaction firewall that returns a receipt of an intent, what you should expect, right, at the end of the day. And it was written for EVM chains, right, specifically for EVM chains, right. So it returns a receipt of an intent, detailed intent of okay, this is what you're expecting. There is no fishy something that will happen when you sign this at the end of the day, right? So because it stimulates an activity and gives you a return reason before you can continue. So yeah, that's just basically what this firewall is all about. And yeah, I I still wanted to build an RPC, right, that helps talks directly to the network. And I was thinking about it actually, but yeah, I've not really concluded on that, but this is just the core, right? But sometimes RPCs can be very, very noisy at the end of the day. Um, um, yeah, but sure, but that's just basically what it is.